Imagine you're sitting on your couch. It's a Sunday night. You're totally relaxed, maybe halfway through a really great movie.
Right. The house is completely quiet.
Exactly. And then suddenly your phone buzzes on the coffee table. You glance down. It's an email from your boss, and the subject line just says, "We need to talk."
Oh, wow. Instantly, your pupils dilate.
Yeah, your heart just starts hammering against your ribs, your palms get clammy, your breathing gets shallow, and your stomach ties itself into this heavy, painful knot.
It's a full-on physical reaction.
It is. It's
Hmm.
honestly as if the Jaws theme song just started playing right there in your living room. And the crazy thing is, you haven't moved an inch. You are in no physical danger, but your body is preparing for war.
Because it's a profound, full-body hijacking. In just a fraction of a second, your biology has shifted entirely away from, resting and digesting and moved straight into survival mode.
Which is such a wild concept when you really stop to think about it. I mean, why does reading 4 words on a glowing screen make your physical, biological stomach actually hurt?
Yeah, it doesn't seem to make sense at first glance.
Right. And even crazier, why does dealing with that kind of invisible psychological stress long-term actually shrink the memory center of your brain?
That's the million-dollar question.
So welcome to the Deep Dive Lab. This is our special scientific investigation space where we decode the secret language of the human body. Because today, we are unraveling one of the most fascinating mysteries in modern medicine.
And it's a mystery that really challenged everything we thought we knew. For the longest time, the medical community treated the mind and the body as if they were separated by this massive brick wall.
Like psychology was over here and physiology was over there.
Exactly. But scientists have finally mapped the hidden biological conversation happening right now between your brain, your gut, and your very DNA.
And to map that conversation for you today, we're pulling from a massive stack of recent medical journals, neurobiology reviews, and physiological studies.
Some really groundbreaking stuff.
Oh, absolutely. Including some incredible research published in Frontiers in Neuroscience, MDPI, and Stat Pearls. We're looking at everything from cellular biology all the way to the clinical extremes of hormone disorders.
Which is a lot of ground to cover.
It is. But the mission today is to shortcut your way to understanding your own biology, and I promise absolutely no medical degree required.
Good, because to understand where the cutting-edge science is right now, we first really have to look at the old medical narrative.
The old way of thinking.
Right. For decades, the explanation for stress was incredibly simple. It centered entirely around one chemical, which is cortisol.
Cortisol. Right. Cortisol was universally cast as the ultimate villain.
Oh, completely.
The bad guy stress hormone. The cultural idea was basically, if you feel stressed, your cortisol's too high, and that's why you feel terrible.
Yeah.
Get your cortisol down, and you'll be fine.
But that oversimplified explanation turns out to be fundamentally flawed. Cortisol is not a villain at all. It is a vital, non-negotiable survival tool.
Wait, really? A survival tool?
Yeah, evolutionarily speaking, cortisol is the hormone that gets you out of bed in the morning. It's what gives you the sudden, massive burst of glucose required to outrun a charging bear.
Okay, so it's energy.
Exactly.
Right.
It regulates your blood pressure, it manages your metabolism, and it aggressively reduces inflammation during an acute physical injury. Without a healthy spike of cortisol every single day, you literally would not survive.
Okay, so let's unpack this for a second. If cortisol is this helpful, life-saving compound, and if our old definition of stress simply meant, having high cortisol, we run into a massive medical anomaly.
The paradox.
Right, something that completely baffled researchers for years. Because when scientists started looking at chronically burned out patients or individuals who had suffered severe long-term childhood trauma, they weren't finding sky-high cortisol levels.
No, they were finding the exact opposite.
Yeah, they were often finding abnormally low cortisol levels.
The clinical term for that is hypocortisolism. And it completely broke the old model. I mean, if chronic stress equals high cortisol, why did the most chronically stressed people in the world have completely exhausted cortisol reserves?
And it wasn't just the hormone levels that were confusing the medical community, right? Psychologists and gastroenterologists were noticing this massive, undeniable overlap between chronic psychological stress and severe physical digestive disorders.
Yeah, the gut issues.
People dealing with severe burnout at work were suddenly developing inflammatory bowel disease, or IBD.
Because the body clearly cannot tell the difference between a life-threatening predator in the woods and a passive-aggressive text message from a coworker.
The reaction is exactly the same.
It is.
Yeah.
But the missing puzzle piece for researchers was the mechanism. How does a purely psychological stressor like a thought, an email, a memory, How does that physically alter human cells and fundamentally change the actual living bacteria inside your digestive tract?
It's so strange.
Yeah.
It's like realizing that your home's burglar alarm isn't just making a loud noise to scare off a thief. It's somehow short-circuiting your home's electrical grid, shutting off the water main, and actively inviting termites into the basement.
That is a perfect way to put it. The alarm system is supposed to protect the structure, but it's dismantling it instead.
So how did scientists figure this out? Because this is where the story gets incredibly interesting.
Well, we have to trace the actual biological wiring from that stressful thought down to the physical breakdown. And it all starts with the command center of your stress response, which is the hypothalamic pituitary adrenal axis.
Usually just called the HPA axis, right?
Exactly. Think of this as the body's emergency neuroendocrine highway.
Okay, so let's track that physical journey because it really is this cascading waterfall of chemical panics. So you see the Sunday night email. Your brain perceives a threat. Deep inside your brain, this tiny region called the hypothalamus acts like a paranoid security guard.
Right, and it releases a chemical messenger called CRH.
And that messenger travels just a few millimeters to the pituitary gland, which is sort of acting like a middle manager.
Yeah, the pituitary receives the CRH and immediately releases its own urgent memo. That's a hormone called ACTH, and it dumps that directly into your bloodstream.
So this ACTH messenger races down through your blood, all the way down to your kidneys, right? To these little triangular glands sitting on top of them called the adrenal cortex.
The adrenal glands, yes.
Right, and the ACTH basically kicks the door down and tells the adrenal glands, pump out the cortisol right now.
That is the exact chain of command, hypothalamus to pituitary to adrenals. And under normal, healthy conditions, this system has a brilliant built-in kill switch.
A negative feedback loop.
Exactly. Once you've escaped the bear, or once you realize the email from your boss was just asking, where you saved a file, the cortisol circulating in your blood travels back up to the brain.
To tell it to calm down.
Right.
Yeah.
It binds to specific receptors on the hypothalamus and the pituitary, essentially saying, threat neutralized, we survived, shut the alarm off.
But something goes terribly wrong when the stress never stops. According to a study published in the journal MDPI by researchers like Sergio Gutierrez Nunez, chronic stress physically breaks that kill switch.
It does. When you are exposed to relentless, daily, unresolving stress, whether that's financial worries, a toxic job, a global pandemic, your brain is constantly bathed in cortisol.
Just constantly soaking in it.
Yeah, and eventually those receptors in the brain become completely desensitized. It's like someone's screaming in your ear for days. Eventually you just go deaf to that specific frequency.
So the cortisol keeps traveling back to the brain to say, shut off the alarm, but the brain's inbox is full. It literally stops listening.
Exactly. So the alarm gets stuck in the on position. The brain keeps sending the panic signal to the adrenals.
And over months or years, those little adrenal glands just become completely exhausted, right? They can't keep up with the demand, which leads to that mysterious hypocortisolism, that abnormally low cortisol we see in severe burnout. The factory just burns to the ground.
And the destruction doesn't stay confined to the brain and the adrenal glands. Because cortisol is a master hormone, it floods the entire body. And its most devastating detour is straight into your stomach.
Oh, man. This brings us to the gut-brain highway, which has to be one of the most paradigm-shifting medical discoveries of the last 20 years.
It really is.
We now know that your gut contains its own independent nervous system. It's called the enteric nervous system, and it has actually earned the nickname of your second brain.
It's an incredibly complex network. I mean, your gut has over 500 million neurons. That is more neurons than you have in your entire spinal cord.
Wow.
Yeah. And they are in constant lightning-fast communication with your actual brain via the vagus nerve.
I always pictured the vagus nerve like this biological fiber optic cable running from the brainstem all the way down through the chest and into the abdomen.
That's exactly what it is. It is a massive information superhighway. And for a long time, scientists assumed the traffic was entirely top-down.
Like the brain doing all the talking.
Right, sending orders down to the gut to digest food or speed up metabolism. But the stunning reality is that 90% of the traffic on the vagus nerve is actually going up from the gut to the brain.
Wait, really? If 90% of the communication is going up, my gut is basically backseat driving my brain?
Essentially, yes.
But I have to push back on that for a second. If the gut is the one driving the panic, why do I feel the stress in my racing thoughts first and my stomach ache second? Shouldn't I feel the stomach knot before the anxiety?
That's a great question. You're experiencing the parallel processing of your nervous system. Your brain processes the initial visual threat like reading the email at lightning speed, but your gut is managing the prolonged emotional state.
Ah, okay.
Your gut bacteria are literally manufacturing your mood. An astonishing 95% of your body's serotonin, which is the neurotransmitter responsible for feelings of well-being, calm, and happiness, is manufactured in the gut, not the brain.
So when the gut environment is disrupted, your baseline ability to feel calm just vanishes.
Exactly.
Let's look at exactly how that disruption happens. Because when that HPA axis we talked about gets stuck in the on position and excess cortisol is flooding your system, it completely changes the physical architecture of your intestines.
It does. Normally, your intestinal wall is a highly selective barrier. The cells lining your gut are held tightly together by proteins, literally called tight junctions.
The junctions.
Right. Their job is to ensure that only fully broken down, safe nutrients pass from your digestive tract into your bloodstream. But chronically elevated cortisol acts like a corrosive solvent on the protective mucus layer of your gut, causing those tight junctions to loosen.
Think of your gut lining like a standard paper coffee filter. It's supposed to hold the bitter, coarse grounds in, while only letting the smooth, brewed coffee drip through into the pot.
Right.
But chronic cortisol is like taking a fork and poking microscopic holes all over that coffee filter. Suddenly, you have a massive problem.
And the clinical term for those holes is intestinal permeability, widely known as leaky gut.
Right, leaky gut.
When those tight junctions pull apart, partially digested food particles and foreign gut bacteria escape from the intestines and leak directly into your bloodstream.
Which is an absolute biological emergency. The blood is supposed to be completely sterile.
Precisely. Your immune system immediately identifies these rogue food particles and bacteria as hostile foreign invaders.
So it attacks.
It mounts a massive, aggressive attack against them, and this creates systemic, body-wide inflammation.
And here is the truly vicious part of the cycle. That widespread immune inflammation triggers an immediate 911 call. It sends a massive distress signal back up that fiber optic vagus nerve to the brain.
And how does the brain respond to a 911 call?
It panics.
Right, it tells the adrenal glands to release even more cortisol to manage the inflammation.
It's a self-perpetuating biological storm. Your physical gut environment is now generating its own psychological anxiety signal, which generates more cortisol, which further damages the gut lining, which lets more bacteria leak out.
It is terrifying. Your own body traps you in a feedback loop.
But it's also incredibly validating, isn't it? For anyone who has ever felt sick with worry, it is not a metaphor. It is not a weakness of character. It is literally happening in your blood and your bacteria.
Absolutely. But the rabbit hole actually goes one layer deeper. To fully understand the damage of this loop, we have to look at the epigenetic twist.
Okay, lay it on me.
Well, a comprehensive review published recently in the journal Biology investigated the epigenetic basis of stress-induced central nervous system disorders. And the mechanisms they uncover are just mind-bending.
Okay, for anyone who hasn't brushed up on their molecular biology recently, let's talk about epigenetics. We hear the word a lot, but what does it actually mean?
It's a great concept to break down.
I like to think of your DNA as a massive inherited cookbook. It contains every single recipe required to build and run your body. Your eye color, your height, your immune system, you can't change the recipes in the book.
Right, the text is printed.
Exactly. But epigenetics are the chemical sticky notes, the paper clips, and the heavy tape that tell the cellular chef which recipes to cook today and which pages to tape shut and completely ignore.
That's brilliant. Your DNA sequence is fixed, but your epigenetic tags are dynamic. They change based on your environment.
So they can be altered.
Yes. And what researchers have found is that chronic stress physically adds chemical tape to very specific recipes. This process is called DNA methylation.
Wait, so the stress is actively taping shut recipes we need for survival.
Exactly. The review in the journal Biology highlights how chronic stress heavily methylates a gene called NR3C1.
Okay, NR3C1.
This is the recipe that codes for your glucocorticoid receptors. Remember those receptors in the brain we mentioned earlier? The kill switches that are supposed to hear the shut off the alarm signal from cortisol?
Yes, the ones that get deaf to the signal.
When chronic stress methylates that NR3C1 gene, it literally tapes the page shut. Your body stops building the kill switch receptors altogether. The chemical tape physically prevents the cellular machinery from reading the instructions. So your stress is altering your genetic software to make you structurally less capable of shutting down stress in the future.
That is wild. The actual architecture of your cells changes. And I know the research in biology also mentions a gene called BDNF. What is that, and how does stress mess with it?
So BDNF stands for brain-derived neurotrophic factor. Think of it as miracle grow for your brain.
Miracle grow, okay.
It's a protein crucial for brain plasticity, learning, and creating new neural connections. Now, DNA isn't just floating loosely in your cells. It's wrapped tightly around microscopic spools called histones.
Okay, spools.
In order to read the BDNF recipe and make the brain fertilizer, the DNA has to physically unspool. This unspooling process is called acetylation.
So acetylation is the unspooling, the opening of the book, basically.
Correct. But chronic stress completely alters histone acetylation. It jams the spools. The DNA carrying the BDNF recipe remains tightly wound up, locked away. You stop producing the fertilizer your brain needs to adapt and learn.
Man, this sounds incredibly bleak. We've got broken alarms, leaky guts, and taped up DNA. But I'm struggling to see how a bacteria in my intestines reaches all the way to my DNA to cause these epigenetic changes.
Right. And this is where the gut connection comes full circle in the most elegant way.
Mm-hmm.
We mentioned earlier that your gut bacteria manufactures serotonin,
Right.
but they also manufacture powerful epigenetic tools. When you eat dietary fiber, your healthy gut bacteria ferment it. The byproduct of that bacterial fermentation is a class of molecules called short-chain fatty acids.
Okay.
And the most important one is called butyrate.
Butyrate. Okay, what does butyrate do in the cookbook?
Butyrate is a powerful epigenetic modifier. It specifically acts as an inhibitor to the enzymes that jam up those DNA spools.
Oh.
So in the language of your analogy, butyrate is the helpful librarian actively pulling the chemical tape off the good recipes and greasing the spools so they can unwind. It ensures that the genes for stress resilience and brain health stay turned on.
Oh, wow. Okay, this is a massive aha moment. So when chronic stress pokes holes in our gut filter and we lose our healthy microbiome, we aren't just losing serotonin, we stop producing butyrate.
Exactly.
The librarian leaves the building, which means we lose our crucial genetic protectors and the tape stays on the DNA.
And the physical implications of this cascade are staggering. When you lose the librarian, you lose the BDNF, that brain fertilizer. Without BDNF, and while you're flooded with the neurotoxic effects of constant unresolving cortisol, you see actual measurable atrophy of the hippocampus.
Atrophy. And the hippocampus is the brain's primary memory and learning center. So when people say they can't remember anything when they are stressed out or they feel like they have severe brain fog, it's not a metaphor.
No, not at all.
Their brain is experiencing structural remodeling. It is physically shrinking.
It is a structural reality, and to truly grasp just how powerful cortisol is as a master architect of your body, we can look at the clinical extremes of adrenal function.
Yeah, let's do that.
Medical literature and stat pearls reviews detail what happens when the system completely breaks down in either direction.
Right, because if you want to understand what a hormone really does, look at what happens when a patient has absolutely none of it versus way too much of it. Let's look at Addison's disease versus Cushing's disease.
Okay, so Addison's disease is primary adrenal insufficiency. The adrenal glands are damaged, usually by an autoimmune response, and they fail to produce enough cortisol.
And without that daily survival hormone, the symptoms are severe, extreme, debilitating fatigue, dangerous, dizzying drops in blood pressure, unintentional weight loss.
Yeah.
And strangely, hyperpigmentation, the skin actually darkens significantly, especially around scars and joints. The body just lacks the energy to maintain baseline function.
Now look at the complete opposite end of the spectrum. Cushing's disease is hypercortisolism. This is when the body is chronically flooded with massive amounts of cortisol, often due to a small pituitary tumor that is constantly screaming at the adrenals to produce more, never shutting off.
And the physical transformation in Cushing's patients is shocking. Rapid, dramatic weight gain, specifically distributed around the midsection and the upper back, creating what's medically termed a buffalo hump.
Right.
The face becomes highly rounded, a classic moon face appearance. The skin becomes paper thin and bruises instantly. Severe hypertension develops.
These extremes really demonstrate that cortisol isn't just about feeling a little anxious before a meeting. It dictates where your body stores its fat, how thick and resilient your skin is, and the structural integrity of your blood vessels.
So, when everyday, relentless psychological stress pushes an otherwise healthy person toward that Cushing side of the spectrum, constantly elevating our cortisol, poking holes in our gut lining, and chemically taping shut our genetic expression, it's no wonder we see skyrocketing societal rates of metabolic syndrome, autoimmune disease, and clinical depression.
It really does paint a seemingly bleak picture of modern life. But synthesizing all of this research actually reveals an incredibly hopeful reality.
Yes, because unlike your fixed DNA sequence, which you inherited and are stuck with, epigenetic tags are completely reversible. You can take the tape off of the cookbook. You can unspool the thread.
You absolutely can. The research clearly shows that we can actively alter our methylation patterns. We can rebuild the gut lining and restore the kill switch of the HPA axis.
And the best part is, the interventions don't require million-dollar pharmaceuticals.
No, they are deeply grounded in our daily lifestyle choices.
So if losing butyrate is what causes the DNA damage, how do we get the butyrate back into the gut? We start with targeted nutrition. We need to feed the bacteria that manufacture the butyrate. That means a massive increase in dietary fiber like vegetables, legumes, whole grains.
And you also need to reintroduce the good bacteria themselves through fermented foods like kimchi, kefir, and traditional sauerkraut.
Which are delicious, by the way.
They are. And increasing your intake of omega-3 fatty acids actively reduces the systemic inflammation that triggers the cortisol alarm in the first place.
And beyond food, sleep optimization is paramount. Sleep is the biological window when the brain clears out inflammatory byproducts and manually resets those HPA axis receptors.
Furthermore, mind-body interventions like meditation and deep breathing have been scientifically shown to alter epigenetic expression.
Because of the vagus nerve, right.
Exactly. When you take slow, deep diaphragmatic breaths, the physical expansion of your diaphragm mechanically stimulates the vagus nerve.
It's like sending a massive all-clear signal from the gut straight up that fiber optic cable to the brain, halting the cortisol cascade in real time. I love how empowering this is. Your genes might load the gun, but your lifestyle pulls the trigger.
That's a great summary.
Every high-fiber meal you eat, every deep breath you take, every night of restorative sleep you prioritize, it is a new biological signal. You are actively commanding your DNA, your gut, and your brain that you are safe.
We're definitely shifting away from a paradigm where we view ourselves as passive victims of our biology. We are the active directors of our cellular health.
Let's bring this all together. What a journey today. We started with the old myth that cortisol was just a villainous stress hormone, and we learned it's actually a vital survival tool that gets hijacked.
Right.
We traced the waterfall of panic from the hypothalamus down to the adrenal glands. We discovered that your gut is literally a second brain, backseat, driving your mood and sending 9/11 panic signals if its delicate coffee filter lining gets punctured.
And we uncovered the wild world of epigenetics, how the loss of butyrate from your gut bacteria allows chemical tape to lock away the DNA recipes you need for memory and resilience.
It really changes how you view yourself. We aren't just isolated individuals carrying around a static set of traits. We are walking, talking ecosystems. We are in a constant dynamic, moment-to-moment collaboration with trillions of microbes and millions of genetic switches.
Which means the power to heal is largely in your hands.
Exactly. The next time your phone buzzes on a Sunday night and you feel that familiar knot in your stomach, remember what's actually happening under the hood. Take a deep breath. Manually stimulate that vagus nerve. Send the all-clear signal.
Protect your internal ecosystem, and your ecosystem will protect you.
Thank you for stepping into the Deep Dive Lab with us today. If you want to keep shortcutting your way to understanding your own biology, make sure to follow, subscribe, and tune in for more fascinating science stories. But before we go, I'll leave you with this final thought.
A little something extra.
Yeah. We know now that our daily stress can add chemical tape to our own DNA. But emerging research into something called transgenerational epigenetics suggests that these chemical tags might actually be inheritable.
That is fascinating.
Which begs an incredible question. If we don't manage our stress today, are we just changing our own brains, or are we physically altering the genetic resilience of our unborn grandchildren? Something to think about the next time you check your email after hours.